Very good evening, sir. Good evening, Ambika. Okay, so let's continue now. Welcome to the class. This is going to be the first session on the same chapter, that is biomolecule. Okay, in the previous class, we already covered the carbohydrate part. In today's class, we are going to start with the proteins. Okay, so protein is the topic of discussion for today's class. So let's start with the protein. First of all, what is protein? If we are discussing about how they play important role in our body, so protein play a very much important role. I'm fine, Ambika. Thanks for asking. How about you? Okay, so protein. I guess you know that in our body, protein further convert into the polypeptides. Okay, polypeptide. As like the simplest form of the food is the glucose here. Similarly, that is they form further. That is the amides. Okay, so wait, that is amide there. So protein, polypeptide, and amide. So let's discuss more about the protein. Actually, what is protein? How about the definition? All these things. Okay, so what is protein? Protein is a kind of polymer. Okay, so let's just talk about the protein. So, what is protein? First of all proteins are polymer. Which kind of polymer? Polymer of alpha amino acid. Okay, so in this case, we are having amino acid. Like what, how it's really look like. So the general structure of the protein or the amino acid is what? That you are having some carbon. Okay, it is connected with some COH group like this way. And this side, this is NH2 group. Okay, and this is some R and this H and this is some R. R can be changed, okay, it can be different, and on the basis of this, we have to divide the protein into so many categories there. Okay, now this group represent amine portion, right? That amine, and this represent that is a acid part. So that's why the complete name become alpha amino acid. Okay, alpha amino acid. So most of the time protein is a part of alpha amino acid. Okay, what is the meaning of alpha and beta? It's same like in the glucose chapter we discuss about capital D, small d, alpha, beta. So ditto, like same thing. We will cover, wait for some time. Okay, so this is a kind of definition. And the third point, the second point, okay, this is the first point. Similarly, the second point, that is the amino acid. The amino acid contain, like this is just a definition, amino as well as carboxylic acid, okay? Amino as well as carboxylic. So both can be present here. Okay, okay, I guess it's visible now. So this is a carboxylic partner. So what? That is the third point. Okay. So I'm writing the third point in the very top. So most of the time, we discuss about the glucose. Glucose are like all are actively optically active. Similarly, in this case, that all the amino acid are optically active except one. Okay. So there is a point that is except glycine. Glycine is the only amino acid. Uh, all other amino acid are optically active. So except glycine, all amino acid are optically active. All amino acids are optically active. Okay, so these points is just not just a statement, like important points. So it's a point number one, it is a point number two, and it's a point number three. So there's a three important point about the protein. Now, let me just explain some more important point to you. Okay, okay, some property of the protein only. So how about the protein property? If we are discussing about the property, okay, statement is really very much important. That's why I am explaining these things to you. Okay, so how about the property of the proteins? So the property number one, that amino acid are soluble in water. Okay, this kind of question asked like soluble in water or what. So the point number one, they are soluble in water. So amino acid are soluble in water. Obviously polar, that's why. Soluble in water. And then second point, that high melting point, really very high melting point is there. Okay, high MP means melting point. Okay, let me just write the full. So it's a high melting point. And third point is the colorless. Okay, they are not colored, colorless, and amphoteric in nature. Not acid, not basic, because both thing present here, acid as well as base. So both kind of property can be given by the protein there. So amphoteric or amphioprotic. Amphioprotic means that more than one proton can be there. So depending upon the condition, we will cover this statement as well. Depending upon the condition, they are amphoprotic. Depending upon conditions. Given, proton connected with H positive given, or and also take H positive. So both can be possibility, like acid as well as base, both can be there. Also take H positive. This is the fifth, I guess, fifth statement. And the last point, naturally amino acid have a L configuration. This is the last point is super important. Okay, so all amino acid, I will tell you how. All amino acid have L configuration. If you remember in the glucose chapter, I told you that most of the time that glucose are the D kind of configuration. Okay, that is the last second carbon if OH present on the right hand side. Very no, this is not last. Okay, because some test still left. Okay, the test part we are going to cover in the next class. Okay, in today's class only the protein. There is some tests like Sullivanov test and then hydrogen test and Bury test. So some important tests. So that part we cover in the next class. Very good evening, Niharika. Okay, so this is the property part. Now, what is L configuration? So I hope you know the what is the meaning of D configuration in the glucose. So similarly, that what is the meaning of N? Okay, so observe this. That this is my COH group. Okay, this is some hydrogen, and this NH2 have to be there, and this is R. When with respect to this COH group, the NH2 on the left side. Okay, this is left side. So this kind of configuration is known as a L configuration. L. Okay, like the glucose. If you remember, recall the glucose. So what was the condition there? That the last second carbon, if OH on a right hand side, so capital D. If OH on a left hand side, so the small capital L. Similarly here, if NH2 present on the left hand side, it is known as a L configuration, and if NH2 present on the right hand side, it's become the D configuration. So like all amino acid mostly have a L kind of configuration. Okay, relative configuration. This is just a relative configuration. Okay, so this is all for the property of protein. Now let's talk about more about the protein. So how the protein look like and all these thing. Now, representation of a protein. How to represent the protein? Okay, so like I know so many things you have to remember, but important. Okay, so like how to represent the proteins. So this table is important. If you're not able to remember so many things, at least remember glycine or aniline. Okay, these two are very much important. So what is glycine? That when NH2 and CH is a common part every time. Look at the CH2 and NH2, and we just keep changing. H is also fixed. This H, the CH2, then CH2, CH2 two time, then CH2, CH is there. So we're just changing that R value here only. Okay, the standard structure will remain same. So what is glycine? Glycine is this when R is hydrogen there. See, this is hydrogen and the short form, the representation, three-letter symbol is the ZLY. Okay, if you are solving the PYQ, maybe you already know that what is GLY. GLY and the capital Z is the symbol here. Okay, for example, how the question frame that if I'm writing that as a ZLY or ALA, okay, so like which kind of amino acid hidden there? So GLY means glycine. Okay, wait, ALA part also we are going to cover. Next thing, look at this when H becomes CH3. See, this is the CH3 and this become alanine. So the first letter, three letter become the symbol here, and the capital A is the letter we are going to use. Okay, next is the vanillin. And in this case, CH and CH2, two times CH3, CH3 connected, it will be like iso group. And well is the three symbol word, and we are using capital V. Okay, yes, they are important. I know like how to remember. If this is very difficult, no. Okay, like the periodic table, you have to revise the table and it's easy to remember. Aspartic acid, and in this is CH2 and COH is there. ASP is the this, and this is important. Aspartic acid, capital D, because it's a different. Okay, all are be like okay, V come V, okay, A Z Z, but aspartic is denoted by the capital D. This is important. Next one, glutamic acid. So in this case, two times CH2. If you want to compare, you can even compare this. Sorry, not this line here. Okay, look at this. Here we are having CH2 and COH is there, and here it's a two times CH2 CH2 means CH2 just adding here. Next, that is a tyrosine. In this case, this is the like CH2CH. So this is very really important, tyrosine again. What is the letter here? Why we are using? Okay, so after the previous one, aspartic acid, tyrosine is the next one, and then lysine. Okay, lysine we can easily remember. Lysine is connected with the NH2 group. Okay, so like this LYS and K is the symbol. Symbol is important. So like different symbol, like glutamic E is the symbol, tyrosine Y is the symbol, and lysine K is the symbol. So we are having total four symbol D, E, Y, K. All are important. Okay, so from this question in the previous year, the which type of question already asked that match the column type. Very good evening, Mayank. Okay, like you have to just simply match the thing like this is a symbol, so this kind of question frame. So yes, symbol is important, and then serine, and then CH2OH, and this is S there. Okay, so the okay, it's simple. Now the important part, the most commonly asked question from this table, that the the group which has alcoholic as a functional group. So the tyrosine and serine, okay, so both are having OH as a functional group. Lysine, that is NH2. Okay, so now let me tell you a kind of mnemonic, like how to remember this. You can skip if you don't want to remember. Okay, otherwise we you can continue as well. So let me just erase this. So I'm not having so many slides, so that's why I have to just write and then erase this. So you can note it down side by side. Okay, so yeah. First of all, remember this like aliphatic. Okay, this is a kind of class. It is just for not only. Okay, otherwise you can directly remember the table. So first of all, that is aliphatic. Aliphatic amino acid. It means in which we are having only the chain is there. Okay, so let me just first write, and then we will discuss about a kind of mnemonic. So in this case, first of all, that is a COH, and like NH2, this part is fixed every time, and hydrogen. Okay, this keep changing R. So hydrogen. Second of that is a COH and hydrogen, and this is NH2, and this is CH3. It's very easy to remember. Okay, this is just for understanding. CH hydrogen, and still this is NH2. It become CH2, CH3, and CH3. Next, that is COOH, hydrogen, NH2, carbon. It is further combined with CH2, CH3, and CH3. This and the last one, COH. Just wait for some time. I know so many things. Just wait. Okay, it's easy. Trust me. And this is NH2 because it's difficult to remember the proteins. So, 3, 4, 5. Okay, so see this. That is first of all, let me just write the proper naming. This is glycine. This is glycine. This is alanine, and this is valine, and this is leucine. I missed one. This is CH2. CH3 aniline and glycine aniline, vanillin. Okay, there is a one more. Okay, okay. Sorry for this. I missed this point there. So it's a valine, and this is leucine, and this is isoleucine, and the last one is what? Proline. Okay, I'm writing here. It's a proline. Okay. So now let's see how to remember this, like which kind of mnemonic device it is. So first of all, you can remember that is glacier. Okay, this is just a mnemonic how to remember. That is glacier at Alaska, victoriously located, isolated, proline. Okay. So see that is you can observe here that G for glycine, okay, A for Alaska aniline, okay, V for vanillin, and L for leucine. Iso means isoleucine, like it's easy to remember leucine and isoleucine, and then proline, that is its same here. Now, what is the point of this line, like what is how it is useful for us? So what is the point to be noted? You can note it here. Look at this, first of all hydrogen, then we are adding methyl, okay, CH3 group, then add two more carbon. So in this case, wait, this is CH3 and hydrogen. See in this case what is happening, that CH3 maintain, we are adding two more CH3 further. So like methyl, then that CH maintain two more CH, and see this CH still maintain, and now in this case three carbon we are adding. Okay, next CH maintain. Okay, now one, two, three carbon we are adding, and the last one is the proline. This is how you can remember. Again, hydrogen, then CH3, then two CH3, then two, three CH, and then four CH, and this is how the chain continue. Okay, I know it's confusing, but take some time, and it's I know it's confusing, but still important. Okay, we can't skip this thing. Okay, because I guess you already solved the PYQ from the biochemistry, so they directly ask the question from here. Like glycine is which kind of structure for the glycine? Aniline, like how would the structure? So structure is really important here. Okay, so this is all for the aliphatic. Aliphatic be like all are the aliphatic. Next, next class. Next is the that when we are having aromatic amino acid. Aromatic amino acid. So how about the aromatic amino acid? That in this case again, you can just observe this is the COH, that like the previous one it is a common, and hydrogen is a common, NH2 is a common. So aromatic means in this case we are having benzene. So see this is CH2 and this is benzene. Done first part. Then next that is a COH and then hydrogen, and this is NH2, and again the CH2 is a common thing, and again this is benzene, and keep continue, this is OH. Okay, so like benzene, then OH. The next is the one more, it is a COH, hydrogen, NH2. Okay, see if structure you are not able to remember, it's not an issue. At least remember like which class they are belonging. Aromatic class, aliphatic, because this kind of question basically asks. So CH2, it is a 5 member ring. Okay, it's 4 member. It's a nitrogen double bond, and this side we are having benzene. So what is the point to be noted here? That aromatic. See, this is benzene aromatic, benzene aromatic, benzene aromatic. Okay, how about the name? So name, this is known as a phenylalanine. Okay, phenylalanine. Okay, most of the time that amino acid end with the name in, okay, and like this. And this is known as a, that is a tyrosine. Okay, it's a tyrosine, and this is, that is the tryptophan. Tryptophan, trypto, you can use any. Tryptophan is there. So now how to remember this again? There is a mnemonic device. So how about that? So pine and timber are trees. So pine and timber are trees. Okay, so how? Look at this again. That you are observing P for pine. Okay, P for pine and P for phenylalanine. Okay, this is how. T timber. Okay, TI. So be noted, if the started from TI, so tie is the name, like TY. And if tree there, so it's starting with tri, so it's become tryptophan. Like this is a most common issue, like how to differentiate between tryptophan and a tyrosine. So timber, TI, so that's why tyrosine, and tree means tryptophan is there. Okay, and out of all the structure, okay, like which is important, that point I also highlighted here. So look at this, this is really important, that this tyrosine is really very much important. Okay, so this is all for the aromatic amino acid is there. Okay, so I hope aromatic part is now clear for you. Now let's cover some other after the aromatic class. Next is going to be the alcoholic there. Okay, so how about the alcoholic amino acid? So alcoholic amino acid, alcoholic one, that CH. Okay, good, that is only two is there. NH2, it's a common one. It is a CH2 and OH. Okay, the next is COH and hydrogen and NH2, and then this is carbon. OH will remain maintained, and this is hydrogen, this is CH3. So it's easy to remember, alcohol is very easy. This is CH2OH and this is CH2, and this extra CH3 we are just adding here. And how about the naming? This is known as a serine, important. And this is a threonine. This is known as a threonine. And how to remember this? That you can remember in this way, that is alcohol is a severe disease. So you can remember, like alcohol means alcoholic group, alcohol is a severe disease. Okay, serious you can say. Serious threat. Okay, I'm sorry. Threat have to be there. So now again, how to observe? So look at this, that A for alcoholic, no, this is not important. Serious. Serious be like serine. And threat means that is a threonine is there. So this is how you can remember that alcoholic amino acid. Next class is for sulfur containing, then acid, and then basic. Okay. So let's see the next class, that is for the sulfur containing. Okay. Anyone, do you know the structure of hemoglobin? Okay, I guess no. So sulfur containing. So how about the sulfur containing amino acid? So in this case, this simple cysteine. If you really like biology, so you're going to like these in here. So it's a NH2, and then CH2 and SH is there. Okay, so like sulfur containing. Next, that is COH and hydrogen, and this is NH2, and this is the CH2, and this is sulfur, and this is CH3 there. Okay, and how about the naming? This is known as a cysteine. It's again important, cysteine. Okay, and this is, that is methionine. That basically we're using a vitamin B12 structure, this methionine. Okay, and okay, I'm sorry, I missed the symbol. This is CS and this is myth. And how to remember this? There's a no mnemonic for this, I'm sorry. So this is sulfur containing amino acid. Now let's see some acidic and basic amino acid, okay? So let's see acidic, basic. So all are important for acid and base. So let's discuss about acidic amino acid. and this side basic amino acid. Okay, basic amino acid. So acidic part, that is when number of COH group, okay, this is important, that when number of COH group is more over the NH2 group. For example, let's suppose that is this is a common thing, right? That this is a general structure NH and this is my NH2. So look at this, that in this case, this is a CH2 and one more COH is there. So look at this, in this case, we are having two COH group as compared to the one NH2. Okay, these two kind of thing is important for the numerical question from this topic. Okay, we will cover the numerical part, pH value, everything. Just wait for some time. And how about the basic? This side, that is the number of NH2 group is more over the COH group is there. Okay, so two kind of acid we are having. Okay, so this is known as aspartic acid. Okay, aspartic acid, and next is going to be the glutamic acid. And the next important question from this topic, that is between aspartic acid and then glutamic acid, which acid is the strong acid in nature? And can you just tell me? Okay, this is just normal. I know it's not biology concept, but still, okay. You have to remember this. Please answer the question. Between the glutaric and aspartic, according to you, which is a strong acid in nature? Okay. Till then, you have to solve the question. I'm writing the basic side. So basic, that is lysine. This part you cover in a GOC chapter 11 class. Okay, lysine. So first of all, it's a COH and hydrogen and NH2 part. And this is basic, so that's why we're having more than two time NH2 group. And this is NH2 part. Okay. And next is going to be the arginine. So what is arginine here? That it's a COH. This type we covered, I guess, in our DNA part. CH2, CH3. Okay, in 11th class. Just let me write the link is. This is known as a CH3. Okay, double bond NH. Okay, this kind. Okay, wait, let me tell you how. That this kind of linkage we covered. That is a double bond nitrogen, and this is NH3, and this is the most basic nature. Okay, NH3. This thing we covered in GOC chapter. So this is this. That is arginine there. So lysine and arginine, and last one is the histidine. Okay, just remember the name of the histidine. The structure is not important here. Okay, histidine. Histidine is there. Okay, name is not clear there, so it's a histidine. Histidine, okay. The stomach wall consists of a thing that is histidine. This is responsible for acidity in our stomach as well. So lysine and arginine, this is the next important part here. Okay, lysine and arginine. Yes, please. What was the answer for the previous question? Between aspartic and glutamic acid, according to which one is more acidic in nature? Anyone? Okay, so listen, that is this is more acidic in nature, aspartic acid, as compared to the glutamic acid. And in this case, which is the most basic in nature, that is arginine. So most basic arginine and most acidic, that is aspartic acid. So that's it. This is all for the structure part. Okay, let me again brief that so that you can take a note. First of all, aliphatic amino acid. Second of what? Aromatic amino acid. Okay, and then sulfur containing, then alcoholic group, and then acid and base. Okay, so this is how we are just classifying the acid. So see this part we just covered, that we are having total two type of classification. First of all, relative number of NH2 and COH groups. So acidic when COH group maximum. Example, aspartic acid or glutamic acid. Neutral when both are same, like glycine, aniline. You can use any example. Or basic means when base, like strong base is there. So lysine and histidine and no, sorry, histidine and glycine and yeah, these are the example. And next one is the synthesis in body. Okay, so you know in our body we are having two kind of amino acid. Okay, okay, how to find? I thought you were not going to ask, but let me just explain to you. Mm, actually, no space left. Okay, let me just add some slide, okay? Just give me some time. Okay, so listen. That if you are having COH and this is hydrogen, this is NH2, okay, and this is CH2 and this is COH, the point number one. Second of what we are having COH and hydrogen and this is NH2 and this is CH2, CH2 and COH is there. Okay, so let's just suppose what is the meaning of acid. We are removing this hydrogen. Okay, let me just erase this and this as well. This is O negative, this is O negative. Okay, so in this case, observe this. You know, acidity is directly proportional to the electron donating concept. So this is COH, and let's count the number of carbon 1 and 2. So this is electron withdrawing group. Okay, so in this case, again, that is count the number of carbon 1, 2, and 3. This is electron withdrawing group. So as you know, here the COH is behaving like a minus I group. Okay, minus I effect is only the you can say which one is applying here, that is minus I. And you know, inductive effect is a distance dependent effect, Mayank, right? So according to that logic, can you just tell me which one is more acidic in nature now? Like aspartic or glutamic. Okay, so is this point clear? That more is the carbon inserting between the COH. If you remember that Ohm's gap topic, remember that Ohm's gap, that sorry, M and S and gap there. So what was the topic? That O for oxalic, M for malic acid. So malic acid is less acidic over the oxalic acid because the distance between the two COH start increasing there. So same concept we are going to apply here. Is this point clear now, Mayank? Okay. First one. So same, you can go with the basic as well. Like if you're observing, in the second one we are having a imidazole linkage there. Just because of that, that basicity increasing there. So anyway, what we're discussing about, that is the synthesis in our body. So in our body, we are having two kind of protein. That one is essential and one is non-essential. So you know what is the meaning of essential acid? Okay, essential acid is the sorry, I said acid, I'm sorry. So what is the meaning of essential protein? The protein which is not present in our body. Yes, with these kind of protein we are requiring from outside. And the second class is known as a non-essential acid. Non-essential means they are synthesized in our body and not required. Okay. So essential means something which is not present in our body. We are requiring from outside. That's why the name is essential. Non-essential, which is not synthesized in our body. We are consuming from food and all these things. Okay. So just basis of this, that we have to classify the acid into total three category. One is essential. Okay, this is just conditional. You can remember or not. It can be okay. But this one you have to remember sequence like essential. Histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and vanillin. You in a paper you are given with some protein and they are asking like which one is essential, which one is not. Like list out five, two, three, four. Okay, so this table is important. How to remember this? You can remember be like this PT Tim hole, okay? So this is the mnemonic PV Tim hole. Okay, like P for phenyl, okay, V for vanillin, T for tryptophan, okay, I for isoleucine, and M for methionine, H for histidine, okay, A for azine is not there, okay, A is not, it's a small L, okay, it's not going to count, L for lysine and leucine, okay, so like it's easy to remember, isoleucine, leucine, okay, and then histidine and some methionine, phenylalanine, okay, so just revise some time and this use this mnemonic pivot Tim hole. So these are the essential amino acid which we are using from outside, which is not present in our body. Okay, this is the only chapter where I'm suggesting you please remember that mnemonic because it's important for you. Otherwise, you know, so many things. And non-essential, okay, no need to remember all the name, just remember some like aniline or acetylene. At least remember this, you know, that if you are given with essential and non-essential, better to remember one category so that we can eliminate the other category. And these are conditionally essential, means if there's a deficiency in a body, so they become essential. If they are already present in a body, so they are non-essential. So like, you know, condition wise. like cysteine, arginine, glutamine, glycine, proline, and that is a tryptosine. Sorry, tyrosine. So this is not that much important. And okay, this is like the complete chart of all the amino acid. Okay, so this is all for the classification of amino acid. It's important. Okay, hardly like one question asked from this amino acid chart, but still it's important, one chapter is important. Yeah, of course. Okay, it's be like difficult, but it's not really difficult. If you, if let's suppose this topic is for biology students, so these names are very chill because they are dealing in every time. Okay, so that's why I told you this chapter is not good for mathematics student. Okay, I really don't like in my time as well, like what is this? So anyway, now let's talk about the molecular behavior. So again, this is one of the famous chapter, sorry, not chapter, that is topic, Zwitter ion. So what is the meaning of this word Zwitter ion? Do you know that actually what is happening? Okay, now my question to you, just answer the question. This is my COH, and after once that it give the H positive, we're getting COO negative. Can you just tell me between A and B according to which one is more stable, stabilized by the resonance? Okay, Ambika. Yes, please. According to you, between A and B, which one is more stabilized by the resonance? I'm not asking which one is stable because answer will obviously A is the correct answer because negative or positive charge is the reason of this, Horo. I know, right? But my question to you, between A and B, which one is more stabilized by the resonance phenomena? Okay, so let's try to understand what I want to ask. So in this case, this is CO, NOH, and in this case, this is R, CO, and O negative. Okay, so look at this. This in this case, oxygen lone pair transfer here, and how about the resonating structure? R, COO negative, and O and positive. The next, this moving here, here, and this is the resonating structure. So can you just tell me between A and B, which resonance is good? Have you heard about the equivalence resonance? Yes, please. Equivalence resonance. So at least can you just tell me between the first and the second or A and B, which one, in which case we are having equivalence resonance? It's not difficult. This is the problem on YouTube. Okay, I guess, lagging. Okay, so let me tell you that this is the most stable because it's an equivalence resonance. So according to the A Harry rule, equivalence resonance lead over the normal resonance structure is there. Okay, so means what is the point? What I really want to explain to you that a Zwitter ion. So in a amino acid, if you are comparing, okay, in a amino acid, look at this. That is this is R, okay, and like this is COH. Okay, hydrogen and NH2. Okay, I know I'm changing the position. Just try to understand my point. So in this case, that if you are observing something that COH, acidic, and this is basic. So in this case, that we are having different kind of scenario. You know how the experiment was conducted in the previous time or in the older time, that just observe the thing actually what is happening. Okay, I'm taking a protein, okay, polypeptide, let's say polypeptide. So in the pre old time how to identify the charge on a proteins or polypeptide. So for example, this is a container. Okay, this is my negatively this is my anode side. Okay, this is positively charged and this is cathode, this is negatively charged. And can you just tell me which kind of electrode it is? Sorry, shell it is. Okay, anyway. Answer electrochemical or electrolytic shell. So if you're using a current from outside and converting to some chemical energy, so it's become electrolytic shell. Okay. So this is electrolytic shell anyway. So in this case, what is the point of observation? Okay, just understand my point. First of all, the pH is 7. Okay, the pH is 7. Simple. Okay, it means no acid, no base. There is a no deflection. But now we're discussing about zwitterine, right? Okay, so let me just erase this slide because today I'm not having slides. Okay, so listen my point. What is the meaning of zwitterion again? That is, this is COH and this is NH2 group. So they're just changing. This will be like I'm base, you are acid. So let's convert. This is CO negative. Okay, and this is NH3 positive is there. So it means this kind of structure is known as a zwitterion. Okay, so like it is a zwitterion. Positive, negative, both balance. Same negative, same positive. It's a balancing. Okay. So at that point of time, if our pH is let's say 7, so battery be like there is no deflection. Okay, why? Because the same negative positive come by neutralize the thing and okay. So this is normal the point. Now the second thing, the pH at which there is a no deflection in electrolytic shell, this is known as a isoelectric point. Okay, just try to understand the point. Don't worry, we are having slide. So listen my point. What is isoelectric point? A point when the negative charge and a positive charge both are equal to one another. Or the pH at which the positive negative maintain. Okay, pH can be 3, pH can be 4, pH can be 7. I'm not saying only 7 is the neutral pH. It can be different for different acid. I'm repeating one more time. Iso means same, electric means electricity, point means a point. Means during the passing of current, a pH at which the negative and positive charge both are balancing one another and there is a no deflection in a battery. The point number one. Now, second point, listen my point. If let's suppose I'm increasing the pH, okay? If I'm increasing the pH, let's say greater than 7. So can you just tell me at that point of time, what is the concentration of H positive ion? Is it increasing or decreasing? Yes, please. If the pH is greater than 7 or pH is high, so H positive concentration is maximum or minimum in the solution. Inversely proportional, right? So it's a minimum, you can say, ma'am. So it's a minimum there. And now it's an equilibrium condition. Okay, so think about it. This is present into the solution. pH is greater than 7 or maximum, and H positive concentration is minimum. So this NHB like, okay, why not you are taking my H positive? Because now in the solution we are lagging in H positive concentration, and this deuterium just try to maintain the equilibrium with the solution. So it give its H positive ion into the solution. Okay, so what was the observation? That at pH is equal to 7, no deflection. But when pH is greater than 7, so now the molecule, just because of the less H positive concentration, needs to give its proton, and we are just left with only the negative charge. So negative charge means it was observed that a protein is moving toward the anode side. Anode side. Why? Negatively charged. Same here, that when the pH is less than 7, H positive concentration start increasing there. So now this time a positive is going to happen. Means what is going to happen? This is already an H3 positive and this CH be like, I have to take the proton because so many proton present. So it become COH group. And again, which kind of charge on a molecule now? That is, there is a positive charge. So it is moving toward the cathode. This is just the point of understanding. I'm repeating again, isoelectric point, no deflection, pH decreasing, H positive increasing, CH taking the proton and then moving toward the cathode side, otherwise anode side. Okay, that's it. This is a concept. Now let me write in a form of statement. Is the concept point is clear for you? Okay, is the point clear for you that actually what is happening? Now let me write the statement. Okay, I know it's so much clearly like what is happening. So let me just write in a form of statement actually what I want to convey here. So first of all, let's understand the Twitter end, right? Okay, this is this slide. Let's observe this, that amino acid behave as salt rather than a simple amine and carboxylic acid. So it is a proton taker, it's a proton donor, both just switching the condition, and okay, it's become a Jupiter ion. This is how the Jupiter ion, typical Jupiter ion look like. It is a dipolar ion. Okay, yes, this question is a board type of question. It's also asked in board exam. Okay, so many times, but it's Jupiter ion. So Jupiter ion form so amphoteric behavior because both positive as well negative, and which can react with both acid as well as base. Okay, but in this case both are maintaining Jupiter ion as a dipolar without any kind of charge on it. Okay, see this is how it's look like. Dipolar, if the H3, you can say H positive concentration increasing. If the H positive concentration increasing, so this side favor. What is it? It's a more cationic form, right? Okay, I guess it's better visible now. So it's a cationic form. So cationic means it is moving toward which electron? That is negative electron. So negative is what? Cathode. So cathode side. And see this, that when H positive OH, okay, OH means simply that, wait, let me just write here that less H positive, pH is greater than 7. Like observe this, pH is 14, maximum pH, pH is 0, minimum pH, strongly acidic condition. Anionic form, negative charge, so it is moving toward the anode. So which kind of question frame, that when pH is less, so on which side of the electrode it is moving, anode or cathode? Okay, so this kind of question asked from this Jupiter ion. Take some time. Okay, I know it's not quick to process for you, like actually what is happening. So much information. Collect some information. Observe this. I'm giving you some 10 seconds. Okay, just add some point that you can write. It is moving toward cathode and it is moving toward anode. This is the brief of the thing which we just covered. Okay, this is all for this Jupiter ion. This is the first type of question frame from this topic. Now let's see the second type of question. Okay, like pH calculation. So I hope it's clear now. Okay, now let's talk about the numerical portion because numerical is much more important. So let me tell you how. For example, you are given with this acid HO, CO, and this is CH2, and this is CH, and this is COH, and this is NH2. Okay, we are given with some value. Okay, so we are given with some values here. So some value be like this is 4.3, okay, and this is 9.7, and this is 2.2. Okay, so question ask, find out the isoelectric point. So find isoelectric point. Okay, this kind of question or numerical ask from this topic. Okay, so what is isoelectric point, ma'am? You said that both are maintained, but see in this case there's a problem. What is the problem? We're having two COH group and there is a one NH2 group. So should we have to consider basic part? Should we have to consider acidic part? So listen my point. Who's the winner? Okay, that one we are going to consider. For example, in this case, 2 COH. Okay, like 1 COH and 2 COH. So they are the winner. Okay, how to solve the question? First of all, observe the number of NH2 group or the COH group. If COH is maximum, we have to consider only COH. So in this case, 2 COH. So COH part we are going to cover. So how to calculate the that is the isoelectric point. So in this case, that one pH, one value, this is just pH value, okay? pH or pH. These are the pH value. So 4.3, second one, that is a 2.2. Add them and then take the average. Okay, so it's become like 6.5 divided by 2, and how much we are end up like 3.3 then 2.5. So this is the final answer of the question. Okay, this is the point number one. Second type of question. This is a question number one. Okay, let's just consider one more type question. Second, it is a CO, CH, CH3 four time, and this is NH3 positive, and this is NH3 positive. Okay, same, please apply the concept, and can you just tell me what is the isoelectric point for this? Okay, let me just write the values. This is 2.18, this is 8.95, okay, and this is 10.79. Yes, please. Okay, what is the isoelectric point for this given question? Some time for you, and please answer this. And the last one is 7, 9, okay? If it's not visible clearly, it is a 7, 9. What is the isoelectric point here? Please answer at least. Okay, 8.45. Hmm. Okay, we're going to take the average, Mayank. Okay, so listen my point how to solve. So in this case, first of all, I'm checking that how many amino acid. Okay. So look at this, two NH3 and one COH group. So who's the winner? That is this NH3 part. Okay. So one pH is that 8.45, one pH is 10.79 and divided by 2, and then we're taking the average. Okay. 7.14. No, which kind of rocket science you're applying? Listen my point. If base is more, so we're taking basic as a point. Okay, if acid is more, we're taking acid like 8.45 and 10.7. So obviously the answer is approximate 9 point something, okay? Because we are taking average. So 9.87. This is the correct answer for this question. Okay. Okay, you're asking second. I'm sorry, 10.79. Okay. I thought you was, I'm sorry, Mike, then, okay? So this is how you're solving the question. Okay, so this kind of numerical ask very easy, but when these kind of question came in the paper, it's be like, oh, what is this? Okay, because we are familiar with the pH only from the chemical equilibrium chapter, and now this kind of question. Okay, so I hope the approach is clear for you, how to approach these kind of question. Okay, Ambika, that's it. So numerical part is done now. Now the theory left. So let's quickly wrap up that. So Twitter and done. Let me just check the topics. Not this. This is done. Okay. Now let's look up the peptides. Now not only the theory part left. Okay. So listen. That what is the meaning of this word peptide? Okay. So listen. First of all, let's suppose this is my COH group. Okay, and this is some carbon and hydrogen, and this is some R, and this is some NH2 group. Similarly, one more. This is a CO and OH, and this is carbon, let's say this is R and this is hydrogen. Okay, so in this case what is happening, water molecule is going to remove. Okay, so there is a water molecule release. Okay, so what is happening, look at this, that NH2 insert between this kind of linkage, okay, is known as a peptide linkage. Okay, peptide linkage. And in term of functional group, we can say this is nothing, this is amide linkage. Okay, so if, let's suppose I said that if I'm having two amino acid, okay, if I'm having two amino acid, how many linkage is possible there? So two amino acid combine, only one water molecule release, and how many peptide linkages, I'm sorry, that is only one. So how, which kind of question frame from this topic, you are given some number of protein, let's suppose 8 protein, sorry, 8 amino acid, and how many polypeptide link is one less. Okay, so this is general concept. So let's see how that. First of all, what is protein? Protein are the that is a polymer of alpha amino acid we just covered. There is so many amino acid A, B, C, and up to so many combined, and in between we are having a peptide linkage. Next, that for example, glycine and aniline combine, and we are getting peptide linkage like COH and NH2 combine, and there is a water molecule simply released there. And now that how the representation G for glycine, okay, A for aniline, so the short form become like gly and ella, so B noted it's be like one glycine molecule combined with one aniline. Okay, so A and B, it can be tripeptide, dipeptide, polypeptide, tetrapeptide, like 1, 2, 3, 4, up to so many amino acid form combine, sorry. So amino acid combine from peptide, peptide combine from polypeptide, polypeptide, peptide combine from protein. So protein, polypeptide, then amino acid. Okay, so like this is how the sequence is going on. So if you want to find out the linkage there, so the number of amino acid -1, so 8 amino acid, 7 polypeptide linkage. Okay, one less because two combine become one. Okay, so that this is how 2 minus 1, it's become 1 only. So this is important formula again. So the second type of numerical frame from this topic is this type. Okay, done. Now let's see the more classification of protein, like fibrous protein, globular protein. Fibrous protein, globular protein means which kind? Okay, so let's discuss some example. This is just for understanding only. So now listen, that is what is polypeptide. You know, so many peptide combined. So when the amino acid in polypeptide chain is greater than 10, so it's become polypeptide. Amino combine peptide, peptide combine polypeptide. And if it's greater than 100, so it's become protein. So protein are the macromolecule, like huge number of amino acid when combined, it's become a protein. Okay, so protein, okay, if it is react with that is a lithium aluminum hydroxide, so amine part is going to convert to the amine there, Shiva. Okay, only the polypeptide linkage is going to break. Okay, so think about it. If accidentally you drink lithium aluminum hydroxide, so in our body, most of the protein is going to break. Okay, Shiva. So like this is how. So let's go again. Next point, that we are discussing about fibrous protein. So what is the meaning of fibrous protein? This is a favorite question of the board examiners. Difference between fibrous and globular protein. So what is fibrous protein? Fibrous protein like structure formed when polypeptide chain run parallel. Okay, so you are having a kind of spiral. You know how this is how the spiral actually they are not straight line. This is how they are present in our body, run parallel and held together by hydrogen bond, disulfide bond, and they are insoluble in water. Example, keratin and myosin. Have you ever observed this, that if you want to that let's suppose you are having a hair, okay, and this is a glass of water, and try to dip that hair into the water. So it's not like after some time water dissolve the hair, no, that water is insoluble in hair is insoluble in water. Keratin is present in our hair, okay, if you know. So it's very important that fibrous protein are insoluble in water. Better to connect the dots. Keratin here, fibrous protein and insoluble in water. Okay, myosin. This is also present in our muscles. Okay, so this is the fibrous protein. Next one, that is a globular protein. That in this case we are having a chain called together in a spiral form. So the previous one parallel chain. Okay, like one chain is like running second here, and now in this case we are having a spiral like one and two. Like all are very completely packed, and they are soluble in water. Example, insulin and albumin. At least you know the albumin, right? You know egg, in inside the egg there's a yellow thing. This is known as a yolk, and that is this globular protein. Okay, and yes, egg is soluble in water. I know in the very first it's not soluble, but after some time stirring it can be soluble, right? So this is albumin. So remember, fibrous hair or keratin, okay, not hair, keratin, and here albumin, that egg yolk. Insulin, you know, insulin injection, that if some when suffering from diabetes. So insulin is also secreted by the pancreatic duct, and it's very important for balancing the sugar level in our body. Okay, so this is all for the insulin. Next, structure of protein. Now, see, definition wise, if you're observing the book primary, secondary, tertiary, it's, trust me, it's going to be very difficult. Okay, but no, we are not going to remember the definition. Just try to understand actually what is primary, secondary, and tertiary and quaternary. Okay, so let me give you a kind of a brief actually what is happening. Okay, so wait some time. First of all, the story be like, just try to make a kind of complex structure. Okay, so first of all, we are having a normal chains, right? That let's suppose that one, this is a one chain, it's a primary structure. Now two chain combine, okay, and form a branching, okay, so many chain combine and branching, it's a secondary structure. Now branch, okay, that there's a so many branching like this, and they start coiling with one another like this, coiled, okay, like this. Not, it's not that much complex, but coiled, it's a tertiary there. And now the quaternary structure, and this is the last stage, that when coiling is that much complex, it's difficult to break. So primary, secondary, tertiary, and four, it's a stepwise direction, chain, then branch, then coiling, and then at the end we are having a complex structure. Okay, so this is actually the protein present in our body. Now let's try to understand with the help of definition actually what is happening and how to remember this, and what is the important point here. So what is primary structure? It contain one and two polypeptide chain. Like I told you just that we are having a straight chain. Example important? No, nothing is important. Okay, only just remember chain. So it's a one or more polypeptide chain, and each polypeptide chain in a protein has amino acid in a specified sequence. Okay, we are having a complete sequence N2C. What is the meaning of N2C? That my terminal end is having nitrogen, so the second terminal has a carbon. Okay, N2C, think about it, carbon nitrogen combine. So if my nitrogen is free this end, so carbon is have to be free on the second carbon. If you are be like, ma'am, nitrogen combine, no, it can't be possible. So it's a nitrogen to carbon terminal end. Sometimes it's be like nitrogen terminal amino acid compound. Sometimes like this is a carbon terminal. So be noted that chain may be from carbon to nitrogen or nitrogen to carbon. Okay, this is how we are going to read the lines. Okay, and example no, okay, not important. You can use any random R and just try to connect them and just simply represent. Okay, next, that any change in a primary structure of a protein, example sequence of amino acid, will be created in different protein. In our universe, there is a billion or trillions of proteins, and every protein has a different sequence. Not even a single repetition in the structure. Okay, so think about it. How beautiful is the universe, like a DNA fingerprinting. Okay, I guess it's better now. Okay, so like nature is a bizarre thing. Anyway, let's see now. Next one, that the secondary structure. Okay, how about the secondary there? So wait, primary, secondary structure. So what is secondary structure? It is further classified into the two part. One is alpha helix, okay, and one is beta plated. Anyone, do you know helix? Have you heard about DNA double stranded helix? Okay, so this is how the spiral. Okay, this is how it's moving. It's be like ladder kind of thing, spiraling. It's like helix. Okay, and in 3D, like this is how it's look like. Okay, anyway, it's very bad, but just try to understand. So this is a kind of helix, alpha helix, and beta plated be like, in this we are having a two kind of, we are having a kind of sheet there, like this. One this, and this is the second one. So they are run parallelly to one another. Okay, let's read the theory. What is actually written here? Okay, so what is alpha helix? Alpha helix structure of a polypeptide chain form hydrogen bonding. This is the key point. That what is the difference between alpha and beta? In alpha form, we are having hydrogen bonding between two chain there, and it is a right-handed. What is the meaning of right-handed? Let's suppose if my pen is sorry, if my pen is moving like this, so what is it? It's which direction? Like we are moving from left to right, it's a right-handed helix. And one, if let's suppose my pen is moving like this, so it's a left-handed, so it's a right-handed, means it's moving like this, okay, like this. Anyway, structure is not important because we are not biology students, so leave that thing. So in this case, that hydrogen bonding in right-handed helix, and NH group of each amino acid consists of hydrogen bonding. Beta plated, that peptide chain runs side by side, and in this case we are having intramolecular hydrogen bonding. Okay, so structure is important. That's a tertiary. It is represent the overall folding of the structure. It's a 3D structure when all the chain combine, and these folding result into the major molecule shape and the globular protein. Okay, so think about it. First of all, we are having a chain, then we are having a branch, and then they combine and form a kind of globe, okay? That is shape, like oval shape, rounded shape, or which kind of shape this is. Okay, so if we are talking about the bonding here, so wait, hydrogen bonding, this is the most commonly asked question. Which kind of force present in the proteins? Hydrogen bonding, disulfide, van der Waal, electrostatic. This is really important topic. Okay, hydrogen bonding and disulfide bond and van der Waal forces and electrostatic forces. Okay, and this is the, okay, let me select this. Okay, it's not moving, I'm sorry. So anyway, in this case you're observing, let me just highlight some kind of bonding here. Look at this. This is you can zoom in your screen, okay? It's a helix there. So it's a hydrogen bond here. Okay, hydrogen bond like CH. No, wait. This is hydrogen bond. This is hydrogen bond and like between the ring, like here. So it's a disulfide bond, two sulfur is there. Okay, this is electrostatic force like plus and minus. And okay, this is a van der Waal forces. Okay, you know this question again asked as a PYQ. Okay, I don't know the advance or main. Okay, you are given with this structure there, and they're just tagging A, B, and C, and you have to identify the bonding there. For example, they are tagging this is A. Okay, they are tagging this is B. Okay, they are tagging this is C, and this is, let's say, D there. And you have to identify like A is a disulfide bond, electrostatic. So this is important figure. Okay, this is an insulin molecule. You can search in your NCRT as well. Okay, so this is important. This slide is super important. Okay, so that's it. Next is the quaternary structure. So some of the protein are composed of two or more polypeptide referred as a subunit, and their spiral combine gives the quaternary structure. So see, this is a brief of all the slide. Primary structure, amino acid we are having. Tell us about the sequence, like N2C, C2N, how the chain is there. Then the shape, like two parallel. Okay, look at this. This is a alpha helix, like this is a spiral, and this is how the sheet, beta sheet. Tertiary coiled, okay, peptide. So first of all amino acid, then beta and alpha helix, then peptides. Peptide become protein. So it's a oral folding, then spiral arrangement. So how the question be like, primary gives sequence, secondary gives shape, okay, tertiary give oral folding, and the quaternary give, that is a spatial arrangement. So this is the complete sequence of a protein. Okay, so this is all for the protein. Now let's see the last topic. Then after this, we are going to end the class. Last topic, denaturation of protein. So what is the meaning of denaturation of protein? Have you ever observed the boiled egg? Okay, in a raw egg, the inside, Simpson physics. Okay. So, in the raw egg, there's a liquid form present into the egg. But after some time, if you have to boil the egg, so that become thick, you know, that yellow portion is now, see that in this figure you are observing, first of all, it's a liquid, 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 and this is how it's become there. Okay, this is known as a denaturation. That there is a some protein when you apply the heat. Okay, so there is a some bonding present in the molecule and they start breaking. You know, we when we're increasing the temperature, vibration bonds start breaking. Okay, they are no longer stable there. So hence this is known as a denaturation of protein. Coagulation of the egg albumin is the best example here. Okay, so be noted, this is really much important here. Now which kind of protein? Globular protein or fibrous protein? First type of question, between fibrous and globular, which is water soluble, globular. Okay, which one is undergo denaturation? Again, the globular protein. Egg albumin is the best example. So when a protein is native, form is in subjected to a physical or a chemical change. It can be temperature, it can be pressure, it can be anything. Okay, it have to be physical or chemical change, and the hydrogen bond are disturbed there. As a result, the protein glob fold and its helix uncoiled and it lose its biological activity. And be noted, only secondary form, tertiary form, okay, is denatured. Primary form never ever going to be denatured. Okay, it will maintain. The second type of question asked from this topic after the denaturation, that Which form? So only secondary and tertiary. Primary form never ever undergo any kind of denaturation, because it's already a straight chain. We are breaking the branching here, not a straight chain bonding. Okay, you know, in thermodynamics, the most commonly asked question, if you have to boil egg, so entropy increasing or decreasing? So what was the, answer during 11th class? Ma'am, it's in decreasing. Why? Because first of all, in egg, we're having a liquid albumin. Now it's become a kind of packing there. So entropy decreasing. But no, see this. That first of all, we are having branching, and now we're breaking the branching. We are having straight chain. So we are moving from less random to more random side. So entropy increasing during the naturation. Be noted. It's a thermodynamic question, right? So that's it. This is all for the denaturation. This is all for the protein. Protein require you know, so much thing. So you have to revise the thing, and that's it. This is all for the protein. Now you are done. Any problem, any doubt, please ask. Next class, we are just left with the nucleic acid, DNA, RNA, or some tests. Okay, yes, please. Any problem or any doubt, so you can ask. Quickly, I'm waiting. Again, watch the recording class, okay? It's important. Okay, thank you so much then everyone. Thank you so much for joining the class and have a nice day. Thank you so much.